All right, this video is on sequences, and we're starting a unit on sequences and series. This is the first video for it. Okay, sequences come to you in a formula. It looks like this, a sub n, and there's an n in the formula somewhere, okay? So reasons that we have a formula, there's three reasons. I'm going to show you three of them. The first one is to build a sequence, okay? A sequence is a list of numbers, like 1, 2, 3, 4, on and on. That's a sequence of numbers. And there's a formula behind how that sequence is found, okay? So in this case, for example 1, if this is the formula for a sequence, to find my sequence, if I want to find let's say I find the first 4 terms. Right? I would plug in 1, 2, 3, 4. So plug in a 1 for n for the first term. 3 times 1 is 3, minus 1 is 2. Plug in a 2. 2 times 3 is 6, minus 1 is 5. Plug in a 3. 3 times 3 is 9, minus 1 is 8. Plug in 4. 3 times 4 is 12, minus 1 is 11. So my sequence then is 2, 5, 8, 11. That's how you build the sequence. Let's try another one. What if n is an exponent? Well, with the first 4 terms, I'm plugging in 1, 2, 3, 4 like always. Now I put in negative 1 up here, so I'm looking at negative 2 to the first power. Well, that's just negative 2. For 2, negative 2 squared, and when you square a negative, it becomes a positive. Negative 2 cubed, that's negative 2 times negative 2 times negative 2, which gives me negative 8. And then negative 2 to the 4th power would give me negative 8 times negative 2 makes it positive 16. Okay? So notice what happened. When the sign was negative, if it had an odd power, it stayed negative. If what was inside was negative, if the power was odd, it stayed odd. The power is odd, then whatever the sign is inside stayed the same. If power was even, it changed. Okay, hopefully you see that pattern. If not, you can always work it out. So my sequence then is negative 2, positive 4, negative 8, positive 16. There's that sequence. All right, to build a sequence, look, we keep doing more examples because they can be more complex. So let's just look at this. If I want to do the first 4 terms again, okay, let's plug in a 1. So 6 times 1 is 6 over 1 squared is 1 times 3 is 3 minus 1. So it's 6 over 2, which is 3. So my first term in my sequence is 3. Let's do 2. 6 times 2 is 12 over 3 times, or let's see, 2 squared is 4 times 3 is 12 minus 1, so that's going to be 12 over 11. Leave it as a fraction, please, reduced. All right, let's try 3. 6 times 3 is 18 over 3 times 3 is 9 times 3 more is 27 minus 1. So this is 18 over 26. This does reduce, so you should reduce it, 9 over 13. And 4, I'm running out of space, so I'm going to do 4 up here. So 4 times 6 is 24. 4 times 4 is 16. Times 4 is, times 3 is 48. Minus 1 is 47. So my last term would then be 24 47ths. Okay, and yes, you'll have your calculators, and you want to use reduced fractions, not decimals, as you do this. All right, let's try one last sequence on building, okay? So if I put in a 1, all right, let's do this. 2 minus 1 over 3, because 3 to the first power is 3. So I need a common denominator of 3. That makes that 6 over 3 minus 1 over 3, which is 5 thirds. Okay? Remember how to make common denominators. Multiply by your greatest common or least common multiple. Okay, so that's term 1. Let's do term 2. 2 minus 1 over 3 squared, which is 9. Okay, so my common denominator is 9 now, so it's 18 ninths minus 1 ninth equals 17 ninths. Third term, 2 minus 1 over 3 to the 3rd power, which is 27. 3 times 3 times 3 is 27. So common denominator of 27. 27 times 2 is 54 over 27 minus 1 over 27 gives me 53 over 27. And no, that does not reduce either. So if I extend my table one last time, 2 minus 1 over 3 to the fourth. Well, I have 3 to the first squared, cubed, the fourth, so 27 times 3 is 81. So common denominator again, 81 times 2 is 162 minus 1. So this is going to be 161 over 81. So my sequence then is going to be 5/3, 17 ninths, 53 27ths, and 161 81st. Okay, notice that's not an obvious sequence, but it is a sequence. There's a pattern to this, okay? Yes, you're going to have to do some of this with reduced fractions. Now, another reason for the formulas, they can help you jump to a certain term. Okay, so you'll have problems that will say, like, find the 10th term. And instead of listing all 10 terms, you can just jump to that specific term by plugging in that value. So on each of these examples, I'm going to just find the 10th term. So I do a sub 10, and I put in a 10 where the n is and solve it. 10 squared minus 6. Okay, well, parentheses first, right? 10 squared is 100 minus 6 is 94 times 10 is 940. Bam, you're done. That's it. What about number 6 here? I want the 10th term. So I'm going to do 10 plus 1 to the times 7. Well, okay, that's going to be negative 1 to the 11th power times 7. Now, one thing you should know, hopefully, is if you have a negative number, or negative 1 to the 11th power, if it's an odd power, it's going to stay negative. If it's an even power, it will become positive because negative times a negative is positive. So if it's odd, it's going to be negative. So it's going to be negative 1 times 7, which is just negative 7. On example 8, oops, I guess this should be example 7, sorry. 10th term again, so a sub 10 is negative 1 to the 10th power over 10 squared. Well, negative 1 to the 10th power, that's an even power, so it's going to make whatever, it's like negative 1 times negative 1. And that would be a positive 1. It's the same as 10 or negative 1 squared because it's even. And then the bottom, it's 10 squared, which is 100. So 1 over 100. I don't reduce it any further. That's my answer. That's how I find the 10th term. It's really simple.